Continuous integration is the most important part of DevOps that is used to integrate various DevOps stages. Jenkins is the most important continuous integration tool. I know you are curious to know the reason behind the popularity of Jenkins and if Jenkins is easy to learn or not. I am pretty sure after watching this video, all your questions will get answered. Hello everyone, this is Shanmukh Chowdary pursuing BTech CSE from Bennett University. Before jumping into the topic, let me just quickly give a short intro about my university. Bennett University is established in 2016 and is affiliated with UGC. It is a philanthropic initiative of Times of India Group, the leading publishing house of India. 30 plus programs and 50 plus technology specializations in engineering, management, media, law, and liberal arts have made Bennett University sought after recruitment destination among the leading corporates in a short time, leading to stellar placement record. So, let's quickly jump into the topic about what is Jenkins actually. Let's first discuss the history of Jenkins. The Jenkins project was started in 2004, originally called as Hudson by Kosuke Kawaguchi, while he worked for Sun Microsystems. Kosuke was a developer at Sun and got tired of incurring the wrath of his team every time his code broke the build. He created Jenkins as a way to perform continuous integration, that is, to test his code before he did an actual commit to the repository to be sure all was well. Once his teammates saw what he was doing, they all wanted to use Jenkins. Kosuke open sourced it, creating the Jenkins project, and soon Jenkins usage had spread around the world. Originally developed by Kosuke for continuous integration tool, today Jenkins orchestrates the entire software delivery pipeline called continuous delivery. For some organizations, automation extends even further to continuous deployment as well. Continuous delivery (CD) coupled with DevOps culture dramatically accelerates the delivery of software. What is Jenkins and why we use it? Jenkins is an open source automation tool written in Java with plugins built for continuous integration purposes. Jenkins is used to build and test your software projects continuously, making it easier for developers to integrate changes to the project and making it easier for users to obtain a fresh build. It also allows you to continuously deliver your software by integrating with many testing and deployment technologies. With Jenkins, organizations can accelerate the software development process through automation. Jenkins integrates development lifecycle process of all kinds, including build, document, test, package, stage, deploy, static analysis, and much more. Jenkins achieves continuous integration with the help of plugins. Plugins allows the integration of various DevOps stages. If you want to integrate a particular tool, you need to install the plugins for the tool. For example, Git, Maven, Amazon EC2, HTML Publisher, etc. So plugins are the heart of the Jenkins. Advantages of Jenkins. It is an open source tool with great community support. It is easy to install. It has 1000 plus plugins to ease your work. If a plugin does not exist, you can code it and share it with the community. It is free of cost. It is built with Java and hence it is portable to all the major platforms. It is easy to use. The user interface is simple and intuitive, extremely flexible and easy to adapt to your purposes. It allows consistent scripting across the operating systems. It has a simple configuration through a web-based GUI which speeds up job creation, improves consistency and decreases the maintenance costs. Before knowing how Jenkins functions, let's quickly discuss what is continuous integration. In the past, developers on a team might work in isolation for an extended period of time and only merge their changes to master branch once their work was completed. This made merging code changes difficult and time consuming and resulted in bugs accumulating for a long time without correction. These factors made it harder to deliver updates to customers quickly. This is where the need of continuous integration came in. Continuous integration is a DevOps software development practice where developers regularly merge their code changes into central repository, after which automated builds and tests are run. With continuous integration, developers frequently commit to a shared repository using version control systems such as Git. Prior to each commit, developers may choose to run local unit tests on their code as an extra verification layer before integrating. A continuous integration service automatically builds and runs unit tests on the new code changes to immediately surface any errors. Continuous integration refers to build and unit testing stages of the software release process. Every revision that is committed triggers an automated build and test. You can see the image shown here. It depicts that Jenkins is integrating with various DevOps stages. Jenkins can also integrate with a version control system using Git, and it can also use to build the code using the tools like Maven. It is also used for continuous integration using the tools like Selenium, and also for configuration management using the tools like Puppet, and also for continuous deployment using the tools like Ansible, and also for continuous monitoring using the tools like Nagios. So you can understand pretty much like Jenkins can do everything from the start of your project until the deployment of your project. In the previous slides, we learned what is continuous integration and what is Jenkins. Now let's understand continuous integration with Jenkins. Let us imagine a scenario where the complete source code of the application was built and then deployed on test servers for testing. It sounds like a perfect way to develop software, but this process has many flaws. I will try to explain them one by one. Developers must wait until the complete software is developed for the test results. There is a high possibility that the test results might show multiple bugs. It was tough for developers to locate those bugs because they must check the entire source code of the application. It shows the entire software delivery process. Continuous feedback pertaining to things like coding or architectural issues, build failures, test status, and file release uploads was missing, due to which the quality of software can go down. The whole process was manual, which increased the risk of frequent failure. It is evident from the above stated problems that not only the software development delivery process became slow, but the quality of the software also went down. This leads to customer dissatisfaction. So to overcome such chaos, there was a dire need for a system to exist where developers can continuously trigger a build and test for every change made in the source code. This is what CI is all about. Jenkins is the most mature continuous integration tool available, and continuous integration with Jenkins overcame all the above shortcomings. Let's discuss how Jenkins functions. First, a developer commits the code to the source code repository like GitHub. Meanwhile, the Jenkins server checks the repository at regular interval for changes. Soon after a commit occurs, the Jenkins server detects the changes that have occurred in the source code repository. Jenkins will pull those changes and start preparing a new build. If the build fails, then the concerned team will be notified. If the build is successful, then Jenkins deploys the build in the test server. After testing, Jenkins generates a feedback and then notifies the developer about the build and the test results. So they even got the feedback from the Jenkins. After that, it will continue to check the source code repository for changes made in the source code, and the whole process keep on repeating. So every time you made a change to the code, the whole process repeats itself. So this is how Jenkins overcame the traditional SDLC shortcomings. Let's quickly understand how Jenkins functions using the diagram. Developers commit the code to the version control system like Git, then Jenkins comes in. Jenkins pulls the code from the version control system and then sends the code for building. Tools used for building are Maven, etc. Then after building, it sends back the executable file to the Jenkins, and then Jenkins sends that executable file to testing. For testing, we use the tools like Selenium, JUnit testing. So after testing, we can find that there are any bugs or errors in the code. So later it reverts back again to Jenkins, and then the Jenkins sends the code for quality analysis. Quality analysis provides the feedback and code review and how the code is written. So if there are any flaws in the code, then developers should know after the quality analysis. So after reverting back from the quality analysis, Jenkins sends the whole code for continuous, either for continuous delivery or for continuous deployment. It depends on the use case and the whole scenario. You can do anything, the continuous delivery or the continuous deploy. Now let's quickly discuss before and after Jenkins. Before Jenkins, the entire source code was built and then tested. Locating and fixing the bugs in the event of build and test failure was difficult and time consuming, which in turn slows the entire software delivery process. But after Jenkins, every code made in the source code is built and tested. So instead of checking the entire source code for bug or an error, developers only need to focus on a particular commit. This leads to frequent new software releases. Before Jenkins, developers have to wait for test results, but after Jenkins, developers know the test result of every commit in the source code on the run itself. The whole process is manual before Jenkins, but after Jenkins, you only need to commit changes to the source code, and Jenkins will automate all the rest of the process for you, like continuous monitoring, continuous deployment, etc. etc. On the whole, Jenkins offers a simple way to set up a CI/CD environment for pretty much any combination of languages and source code repositories using pipelines, as well as automating a number of other routine development tasks also. While Jenkins does not eliminate the need to create scripts for individual steps, it does give you a quicker and more robust way to integrate your entire chain of build, test, and deployment tools than you could easily build yourself. I hope this video made clear everything about what is continuous integration and why Jenkins is actually a popular tool for continuous integration and how Jenkins functions. Thank you.